Complex variable. What is a complex number? So any number which is a complex number, any number of the form z is equal to x plus jy, this is called a complex number, where this is the real part and this is the imaginary part. Okay, now this number, for example, can be z is equal to 1 plus j2, and this can be represented on a plane. This is called Argand plane, where this part is the real axis and this is your imaginary axis. So how to represent? From here we see it is 1, so say this is 1, this is 2, and here it is say 1, this is 2, 1 2, so 1 and 2 on this. So this point, if this is plus minus, then this would be plus 2 and this is minus 2. So this is our plot on the Argand plane. Now next, let us see some properties. Say z is equal to x plus iy, where I is equal to j. Okay, and this is equal to negative of minus 1 under root of that. Then z bar, which is the complement, is given by x minus iy. This is called as complement of z. Now next would be z plus z bar. This would give x plus iy plus x minus iy. This is equal to 2x. This is completely real. Similarly, z minus z bar, this would give 2iy. This is totally imaginary. Okay, similarly, z into z bar, this would give x plus iy into x minus iy. This would give x square plus y square, and z upon z bar, this will give x plus iy upon x minus iy, and this is equal to x plus iy upon x minus iy into x plus iy upon x plus iy. This gives x plus iy square upon x square plus y square. So this expression can be expanded into real and imaginary parts. Okay, another thing is argument, or in simple word we call this as angle. So example, z is equal to 2 plus 3I. For this, on the organ plane, we can represent it like 1 2 and 1 2 and 3. So this is our point, that is this point, and so connecting this point, and this is the angle theta. So tan theta is equal to perpendicular upon base, that is equal to, this is 3 divided by 2, or theta is equal to tan inverse of 3 by 2. This is so argument of z is equal to theta is equal to tan inverse of imaginary upon real. So remember this one. Now let us solve one question. GATE 2014. Find argument of 1 minus I upon 1 plus I. Okay, now solution. So it is very simple question, and you just z is equal to 1 minus I upon 1 plus I. You just multiply, divide on numerator and denominator with 1 plus I, so you will get 1 minus I square upon 1 square plus 1 square. From the previous formula we have already seen, this gives 1 minus 1 minus 2I upon 2, and this gives minus I, and this is equal to 0 plus I. So argument is equal to tan inverse of imaginary equal to 1 minus 1 upon real equal to 0, that is equal to infinity. Negative of that, so this gives minus pi by 2. So this is your answer. Okay, now let us take one more question from the same year, 2014 GATE. Find argument for 2 minus 3I upon minus 5 plus I. Again, this is a very simple one, and proceed in the same manner. Z is equal to this given, so this is Z is equal to 2 minus 3I into minus 5 minus minus 5 minus I divided by minus 5 plus I upon minus 5 minus I, and on solving this you will get minus 13 plus 13i divided by 26, and this is nothing but minus 1 by 2 plus I by 2. So theta is equal to tan inverse of minus 1 by 2 divided by 1 by 2, that is equal to minus tan inverse of 1, this is equal to minus 45 degree. So this is the answer. Another question, K 2011. So in this, a point has been plotted in a complex plane as shown in the figure 1. In the figure 1, a point has been shown to be plotted here, Z. This is given, figure number 1, and this is a unit circle. This is a unit circle, a real axis, and this is imaginary axis. Now question is, then the plot of this is given for Z, then plot of complex number y is equal to 1 upon Z, and the options are A, this is 1 and your y is here. Question figure B, figure B is y is lying here. Option C, y lying here, and option D, your y lying here. Okay, so this is a very nice question, and let us see how we can proceed it. So you can see that this question, Z is given in your quadrant 1. Z we can see in quadrant 1. This is first thing, and second, it is Z is less than 1 since lies inside unit circle. Okay, so these are the two key points to be observed. Now how to proceed about the question. So first we can find magnitude, and also we can find the argument. If we are able to find these two for y is equal to 1 by Z, then we can solve this question. So we can, okay, so how to proceed? Z is equal to x plus iy, 1 by Z is equal to 1 upon x plus iy. This is nothing but x minus iy upon x square plus y square, x upon x square plus y square minus I y upon x square plus y square. Okay, so this is our real and this is our imaginary. Then since z lies on first quadrant, so x is positive, y is positive, and these means that x upon x square plus y square would be greater than 0 and minus y upon x square plus y square, that would be less than 0. Okay, so if you see plus plus minus plus minus minus plus minus, this is real, this is imaginary. So here we have got real, positive, imaginary, negative. This implies fourth quadrant. Hence option A or D. Again, z is greater than 1, this implies 1 by z is less than 1. This implies should be sorry for the mistake. This was actually z was less than 1 because inside unit circle this implies 1 upon mod z is greater than 1. This implies should be outside unit circle. This implies your option D is the answer. Okay, so question was quite easy one, but it does contain the concept. Now moving on to the next things, complex variable, a very important topic, and that is analytical function. Analytical function, or this is also called as homomorphic equation. Homomorphic function. This is quite important in forgate point of view. Okay, now what is an analytic function and how can we define it? So it's quite a easy one. Definition. So single valued function is said to be analytic at z is equal to z0 if it is differentiable at z is equal to z0. So if it is a differentiable at z is equal to z0, then it is called as analytical function. But if not differentiable, then it is called a singular point. That is, z0 is called as singular point. Okay, so this is just for the sake of your understanding. You would understand the concept better when we solve the questions. Okay, so based on this, we have a lot of questions coming in GATE. Say for instance, this is GATE. Okay, this is not a GATE question, this is general question. We are going to see some question to check if the functions are analytic. So we have seen the definition of a function to be analytic, but how exactly we should proceed about solving it, I haven't talked about yet. Okay, so let us see that thing. For that we are going to see an important equation that is called as Cauchy Riemann Cauchy-Riemann equation. This is a very important equation and you must understand it very well. It is very simple to understand. Okay, note that this is sufficient and necessary condition, or I should have written this first, necessary and sufficient for any equation to be analytic. So for any equation to be analytic, it must obey Cauchy-Riemann, shortly represented as CR equation. Any analytic function. Okay, so any analytic function must obey CR. Now what does it say? If we have a function z is equal to u, which is a function of xy, plus I v, which is a function of again xy, then according to CR, According to CR, del u upon del x is equal to del v upon del y. This is equation 1. And del u upon del y is equal to minus del v upon del x. So this is your equation 2, and these two combinedly are called as CR equation. Okay, so now going again back to the question, function to be analytic. First one, fx is equal to mod of z into z. So solution, okay, so z is equal to x plus iy, or mod of z is equal to under root of x square plus y square. This implies mod of z into z is equal to x square plus y square into x plus I y, and this is going to give you x into under root of x square plus y square plus I y under root of x square plus y square. So this is our real part, or u, and this is our imaginary part, or v. Then according to CR equation, del u upon del x, this is going to give you solve it, we get x into 1 by 2 x square plus y square minus 1 by 2 into 2x plus under root of x square plus y square. And del v by del y, again same, y into 1 by 2 x square plus y square minus 1 by 2 into 2y plus under root of x square plus y square. So this is your equation 1, and this is your equation 2. This can further be simplified into y square upon x square plus y square plus root of x square plus y square, and from that you get, sorry, here 2 is also there, 2y square plus x square upon under root of x square plus y square. So let this be equation 2. Also simplifying equation 1 we get this is equation 2, we get equal to equation 2. Hence del u upon del x is equal to del v upon del y. So the first CR equation is satisfied. Thus function is analytic.